The objective of this video is to teach you a little bit more about hydrocarbons and their different types. There are alkene, alkane, and alkenes, and also their substituents, the alkyl group substituents. Also, we are going to teach you how to name and draw the structural formulas from hydrocarbons, especially alkanes, and also we are going to tell you some important facts about them that maybe you didn't know and will be useful to learn and understand better this topic. Hope you like our video and it is useful for you.
Hello, in this video we will help you to learn and memorize about how to name hydrocarbons. First, we will talk about the UPAC. The International Union of Pure and Applied Chemistry, UPAC, serves to advance the worldwide aspects of the chemical science and to contribute to the application of chemistry in the service of humankind. As a scientific, international, non-governmental and objective body, UPAC can address many global issues involving the chemical science. One of its functions is the nomenclature of hydrocarbons. This is a very important function because without it, we will be able to distinguish between different hydrocarbon compounds, and when we use them, it could be the wrong compound because some of them have the same quantity of molecules. When different carbon compounds have the same chemical formula and different structure, they are called isomers.
Do you know what hydrocarbon means? No? Really? Well, in this video we'll show you what hydrocarbons are and what's their classification. So let's start.
And then there's the hydrocarbons, only carbon and hydrogen. And these are divided into saturated hydrocarbons, which have single bonds, and the unsaturated ones are where they have multiple bonds. Multiple bonds meaning not more than one single bond, but meaning double, triple bonds, things like that.
So, what are alkanes? Alkanes are organic compounds that consist entirely of CnH2n plus 2 and can be subdivided into the following three groups: the linear straight chain alkanes, branch alkanes, and cycloalkanes. Alkanes are also saturated hydrocarbons. The UPAC rules were created to phase out old names such as toluene and replace them with a system that will be consistent, as well as providing information about the placement of substituents. The atoms or molecules like attached in the hydrocarbon chain. So, to name our hydrocarbons, first we need these prefixes so we can name them. 1-meth, remember, 1-meth, 2-eth, 3-prop, 4-but, 5-pent, 6-ect, 7-ept, 8-oct, 9-not, and 10-dect. For alkanes with branch carbon chains, determine which chain is principal chain. The principal chain is the longest continuous carbon chain. If two or more chains in the structure have the same length, the principal chain is the one with the most branches. Number the carbon atoms of the principal chain from one end to the other in the direction that gives the lowest number to the first branching point. Name each branch and identify the carbon number on the principal where it is attached. For branch names, use the name from part 1, but remove N and add EL, YL, like methyl, propyl, etc. There are certain special groups with their own names, such as isopropyl, 3-buthyl, and isobathyl. Okay? Then, construct the molecule name by adding the carbon numbers of the principal chain where it's attached, then a hyphen, the name of the branch, and finally the name of the principal chain. This is branching, hyphen, branch name, principal chain name. Note that there are no spaces such as the branch name and principal chain name in one word. If the principal chain contains more than one branch, each branch receives its known number. Use the prefixes D, 3, tetra for 2, 3, 4 identical branches, of course respectively. If substituent groups add more than one carbon of the principal chain, alternate schemes are compared. The one that gives the lowest value is used. Substituent groups are cited in the name in alphabetical order, regardless of the order of occurrence in the molecules. Prefixes di, tri, tetra, and tert are ignored, but prefixes iso, neo, and cyclo are not. If number of different groups is not resolved by other rules, first cited groups get in the lowest number. If more than one name branches get same node from side the number that changed, such as the sum of the number of the branch, carbons must be lowered.
Well, in this video, I will explain you the steps of how to draw an structural formula of an alkane. There are 5 simple steps you will follow in order to draw a structural formula for an alkane. The first one is to draw the main chain, that is the longest. And you will find first in the name that usually is the last word of all the name. That will indicate you the longest chain, the number of carbons, that will be your longest chain. Then you will do an escalator, a straight line of carbons. It can be in a stair or horizontally or straight, but it should be the longest and it should be continuously. You will draw skeleton carbons only, so it will be easy for you to draw them and fulfill all the next steps I will explain you. Then you will number the carbon in the pattern change in this way, so it will be easy to locate the position of each of the carbons. The next step is to place all the alkene groups substituents in the right place. These numbers that we will position before, it will make them easier. So to place the alkene group substituent, the next step is to join the carbon atoms with a dash that will represent the bond between each atom in this way, or it can be like here. These dashes will represent it, and in here also, this is the bond between each carbon. This will represent it. Then the next step is to fulfill the rest capacity of carbons atoms with hydrogens atoms in the way that doesn't exceed the 4 bonds our carbon can make. Yeah, well, you can fulfill these bonds. We have 2 carbons here, and here is our bond. So carbon can form 4 bonds in total. We have here 1 H, and this one is 2, and is missing another one. So we are placing 3 here in order to fulfill the 4 bonds. 3 hydrogens are attached. You can represent it in this way or in this way, that is more expanded, and this is our 4 bond. And this will be the same as another one. There are only 5 simple steps, so in order to draw it, I will give you an example, so it will be easy for you. I will let here this instruction, so it is easy to you to remember. Okay, we have this name, that is 2,3-dimethyl-5-propyldecane. This means we have to first find our longest chain, that in this case will be decane. Decane means 10 carbons. We will place it here. So we first find our longest chain and draw the skeleton carbons in this way. We need 10. 5, 6, 7, 8, 9, and 10. We have in this way 10. Then we number the carbons, the pattern chain, in this way, so it is easy for us to position later the alkene group substituents. Okay? Now that we have the longest chain, we have numbered the pattern chain, we will join each carbon with a dash that will represent the bond between them in this way. After that, we need to find our substituents, right? That will be methyl and propyl. because of the termination that it is here, the suffix is there. That indicate us that it is a alkyl group substituent. And these numbers represent the position of its substituent. Well, we know that by this D that we have two methyls because it's a prefix that means two. After we know that we have to place two methyls, that it is a one carbon that will be represented in this way, and in the position 2 and in position 3. So we find position 2 that is here, and we place our substituent, and then we find position 3 and place our other methyl in the correct place. We have our other substituent is propyl. That means we have 3 carbons, and we represent it in this way. This will be our propyl. It means that this is in position number 5. So here we put it in position 5 in this way. Here is a 2 and then a 3. Now we have our longest chain. We have our substituents. We have our number, our chain. So the next step and final step is to fulfill the bonds that carbon needs. In this case, we have only one bond, so we need 3 more. In this case, we have 3, so we only need 1. In this case, it's the same. We have only needed 1. These have 2, so we need 2 hydrogens more. These have 3 bonds, so we only need a hydrogen, 1. This one has 2, so we need only 2 to fulfill the 4, and so on. This one is the same, and this one is exactly the same. And the last one will be deception because we only have 1 bond, so we need 3 hydrogens. And that's the way we draw a structural formula for alkanes. We have the names, the numbers represent the position of each substituent. It also can represent the position of a bond, but in this case we have the termination of alkane. So ane, the suffix means 1 bond. In the case we have like in, we will have 2 bonds, but we don't have it, so it's only 1, and we will not place it because all the chains will have 1. The other suffix we could find will be ane, that means 3 bonds. And in the case of substituents, the suffix is il, and this indicates us that is a alkene group substituent. Yeah, and that is everything you have to know in order to draw a structural formula for an alkane. I hope you get the idea of how to do this.
Alkenes are a class of hydrocarbons that contain only carbon and hydrogens. They are unsaturated compounds that contain at least one carbon-to-carbon double bond. Another term that is often used to describe alkane is olefins. Alkanes follow the naming convention of the alkane. Alkenes follow the naming convention of the alkanes, except that the suffix "n" is used instead of "ane". "ene" is used instead of "ane". For alkanes above propane, the position of the double bond must be specified in the name. The double bond in alkanes can act to bond such molecules together in long chains and sheets. The formation of polymers is an important area of chemistry.